Back for more, I see. So an important idea in polynomials is like in unlike terms. It's a great way to simplify polynomials or to add polynomials, subtract polynomials, anything you want to do with polynomials. It's much better to add or subtract like terms. But in order to add or subtract like terms, we have to have a definition what is like and unlike. Like terms, algebraic terms have to have the same variable with the same degree. Nothing to do with the coefficients or the numbers, just we're talking about the variables. So 4x and negative 5x are like because they are the variable x raised to the exponent 1. So we consider them like. The following are considered like. 5 is like 6. Why is that? Well, 5x to the power 0 and 6x to the power 0, that's 5 and 6, written in a really weird way, is the same variable, same exponent. Or, you probably know that 5 is like 6. They're both numbers. 4 or negative 4x and 7x are like. I know one is negative and one is positive, but it really doesn't have anything to do with that. However, both contain the variable x. Yeah, that's the first condition that is being met. And both are raised to the exponent 1. Similar with 4x squared and 102x squared. Now, the coefficients don't matter, the numbers don't matter, but it's the same variable raised to the same exponent. Last but not least on our list, 16x squared and negative 16x squared are like. Same variable, x, raised to the exponent 2. So we consider these like. And we can add or subtract like terms because can be grouped as almost like being having the same elements. So we can add apples to apples, but not apples to oranges. Unlike. Now, unlike terms, they're algebraic terms that either have different variables or raised to different exponents. So in my first example here, 5x and 5. These are unlike. Why is that? Because 5x to the power of 1 and 5 is really x to the power of 0. So we have to consider these not like or unlike. Next example. Now, I've written these intentionally to be similar. So 4x squared and 4x are unlike because 4x is to the exponent 1. So although we have the same variables, they're raised to different exponents. I'm going to switch my colors to blue. 5y and 15x are also unlike. We have different variables, x and y. I'm just going to give you possibly one more example of unlike. 5x is unlike 5x. Why? Because one term has a y variable. Now, just to make this more fun, 5xy squared is unlike 5xy because we're missing a squared term above the y. So really, the variables have to be the same and raised to the identical exponents. So one of the important tasks in algebra is being able to simplify polynomials. We can simplify polynomials by grouping the like terms within each polynomial. Combine like terms by adding the coefficients within each group. All right. So if you take a look at my examples here, you're probably noticing I'm going to use colors. And what I'm going to do is I'm going to color each like group. So let's take just going to take an eraser to all of this, and we're going to start from scratch, shall we? So, example, 4x squared plus 7 minus 4x plus 3x squared minus 2 plus 2x. Well, that's a mouthful, but first thing I'm going to do is I'm just going to highlight 4x squared, the term that is on the most left. I'm going to look at the rest of my polynomial. Is there any other term that has the same exponent to the same degree? Sure, that's 3x squared. Next, 7. 7, is there any other term that is a constant? Sure, that's negative 2. Now we forgot to do one thing with the blue, is there are no other terms like these. Next, I'm going to highlight negative 4x. Is there any other term that is like negative 4x? That is, it's x raised to the power of 1. Sure. That's 2x, so positive 2x. So when we work with polynomials, it's really all about organization. So now I'm going to start to organize. I'm just simply going to move around my terms. So I'm going to group everything that's blue together, blue. So anything that's x squared together, I'm going to put together. Anything with just x to the power of 1, I'm going to move together. Anything with that's a constant, I'm going to put together. There we have it. Now, what I've done is I've organized it so it looks a lot nicer now. And I am going to perform the operation that is being described within each group. Now, combining like terms by adding the coefficients within each like group. So 4x squared plus 3x squared. I'm going to do this blue group, or the x squared group. Well, 4 plus 3 is 7x squares. Negative 4x plus 2x. No, negative 4 plus 2 is negative 2x. Variable comes along. 7 minus 2. Well, I think I've done this many times before. 7 minus 2 is 5. There we have it. I actually think that organizing by color when we're first starting out with polynomials is going to be very important. This next group. I'm just going to highlight negative 5x squared. I'm going to look through the rest of my polynomial. Is there anything that is like this? Sure. And that's positive 5x squared. There's no other term that has an x raised to the exponent 2. 4 is the next logical choice. Now I'm going to look, is there any other like terms? Sure. And that's negative 3. Next, negative 7x. Is there any other like term? Yeah, positive 3x. So within each group, each of them has the same variable raised to the same exponent. Now the reason why I'm going to organize this is I'm going to organize this in the highest exponent. So I'm going to say negative 5x squared, and I'm just going to add 5x squared. Then I'm going to work with the x or pink group because that's degree 1. So I've dealt with degree 2. Now I'm going to work with degree 1. That's all very nice. And then basically I'm just moving each of these terms and not doing any math. This is just pure organization. I'm moving each term so that each like terms are beside the other ones and in descending order of degree. So the purple group is degree 2, the pink or red term is degree 1, and the blue term is degree 0. Quite simply, I'm just going to perform each operation within each group. Negative 5x squared plus 5x. This is going to be 0x squared. Now, negative 5 plus 5 is 0. X squared is along for the journey. So when we're working within each group, when we're adding or subtracting, we can think of the coefficients as almost being independent of the variables. Negative 7x plus 3x. Negative 7 plus 3, well, that's negative 4x. 4 minus 3 is 1. So this is 0x squared minus 4x plus 1. However, whenever we have a term with a 0 coefficient, we typically omit it or we leave it out. I would probably write this as, I would most definitely write this as negative 4x plus 1. And that brings me to two important points. One, coefficients of 0. If the coefficient or constant or coefficient is 0, then we often do not write that term. So for example, 0x squared plus 4x, I would probably write this as 4x. And if I wanted to, I could put plus 0, put my constant term as plus 0. I still write this as that. The next one is when I have a coefficient of 1. If the coefficient is 1, we often do not write the coefficient. So my example here is 4x minus 3x. We know that this is just 1x that is left over. Typically, I don't write it as 1x, I just write it as